So I will start. So after completion of this SQL, we have the topic called the spaces and tables. Yeah. It means there are different spaces to store the data. So to understand this, let us see. Okay, when we create a table and when we store the data, where the data stores. Okay, the data when we insert into the tables, okay, that has to have some space where it can hold the data for us, so that whenever we query it, it can return it back. Right? So that space in which the tables store their data is called as permanent space. So okay. It is called as permanent space. Yeah, and we'll call it as pump space also. The space which is required to hold tables data. Can you tell, what all other data to be held permanently except, a part of tables?
Views?
Does views hold data?
No.
Yeah. Views are to use the existing data in tables itself. Just it is a window. It will access tables only internally.
Okay.
Any other objects which hold their own space? In Teradata, you can think of
Store path?
secondary index.
Hmm.
Right? Secondary index. Why? What happens when I create a secondary index? It would create a subtable which holds three-part key. Right?
Okay.
It is a subtable and it is also distributed across all the amps. So the secondary indexes will hold its own data.
Okay.
So these are some of the objects which holds space in their permanent space, the permanent space. The tables, secondary indexes, and stored procedures to save their definition, not for the data, for the storage of the definitions. The stored procedures will also use the permanent space.
Okay.
Okay. And after I store the data, when I try to retrieve the data, okay, I write select queries. So when I write select query on the table, suppose I am doing some joining between employee table and DEPT table, I am retrieving the data with the select query. So it has to pick the data from table EMP and then again pick the data from table DEPT, and it has to do the join as per the given condition and retrieve the rows. Okay. So to have these tables temporarily in some space so that I can join and I can massage and I can retrieve the data, we need one more space, temporary holdage space, the intermediary space which is required to keep these tables in for some time and then do the join and then provide the result set to the user. Okay, so the intermediary space, okay, that is called as spool space. We have permanent space which holds the data for permanent. Okay, we have an intermediary space where it can be used as workspace, okay, for the tables to pulling in and to do the transformations or joins or aggregations, ordering, sorting, whatever operations we ask to perform on the data. Okay, that data will be massaged in this space, intermediary workspace. Okay, that space is called spool space. Okay. And this spool space is used by all the retrieval queries, all the queries you can say, right? So if it is an update, then also it may happen through joins also. The update with joins, update with deletes, delete with joins. Okay, whatever query it is, if internally it is asking for some temporary data to hold and then do the operations, then every query will use the spool space intermediately. Right? So let us see first these two spaces. Okay, pump space and the spool space. The spool space is the intermediary workspace. Space used by queries to hold the. So this spool space used by these queries will exist for how much time? Okay, till the query execution only. The lifetime of spool space exists till the query execution. After the query completes, it flushes off the spool space and the space which is freed up can be used by some other queries. Okay? Like that, the spool space is a workspace for intermediary purpose. It will use the space, and once the query executes, it will be flushed off and the space can be used by some other queries. So these two are the properties which we define at the time of database creation itself. Okay. While creation of database, we will give the parameters how much permanent space this database or user has to have, or how much space this spool space, how much spool space this database can use. Okay. If you give database definition, okay, so it is at the database creation. So generally, who does this database creations? DBAs or the architects level. Okay, so as a developer, we will use the existing databases, okay, but we never get a chance in real time to do this database creations. Okay, so now I will just show you a database, how it will be created, and then you can understand what are the properties we set at the time of database creation. Okay. And then coming to tables, we have three types of tables. Okay. The first one is called derived tables. Okay, so these are the types after our permanent tables. Okay, our permanent table is there where we create and we insert data that uses the pump space. Okay, those are the pump space tables, the permanent tables. Okay, after that we have three types of tables. The first one is called as derived table. Okay, why it is called as derived table? Because while execution of the query for permanent purpose, if you want the result set to be materialized and can be used in rest of the queries, okay, we can have a table to be derived within the query and can be used within the query and then be flushed off after the execution of the query. Okay, so like this, we can create a table. Okay, we can derive a table within the query itself and can use within the query and can destruct it within the query. Okay, so the lifetime of these derived tables are within the query. Okay, and they use this spool space because it is for the permanent, it is for the intermediary purpose of query execution. Okay, so the space used by this derived table is spool space, and the lifetime of these derived tables are till execution of the query only. Okay, so let us see an example of a derived table. So this is the example of the derived table. This is the main query, and within this you can see the red font is for the derived table. It seems like a subquery, right? It seems like a subquery, but in this subquery, whatever columns derived within this subquery, we cannot use them in the upper query to select it, right? We generally use it for comparison, where this in subquery starts, and in subquery we will select some more columns and we'll use these columns for the comparison with the outer query. And that is the normal subquery. But here if you observe, okay, the table is created, the query is written as a subquery, but after this we started naming this table. Okay, so I have written this query so that the average of amount from the sales table is selected here, and then I'm naming this entire data with a table called mytemp. Okay, and whatever columns selected within this query are named as a column average salary. Okay, so mytemp is the table name and average sal is the column name which is derived within the query. Okay, so now mytemp is a derived table which holds average salary. It may be one column or one row, okay, that we have materialized within name mytemp average sal. Okay, so this particular query will know what is this mytemp is and what are the columns in this mytemp, so that I can use this elsewhere in the query. Okay, if you see where we used it, average sal, okay, we have used it in select clause of the outer query. Okay. So generally it is not possible in case of subquery, right? Whatever columns we derive or whatever columns we select in the subquery, it can be used to for the comparison purpose with the outer query, but not used for any conditions or in the select clause of the outer query. Okay, but here, okay, in the derived table, as we have materialized with the table name and we have given column names, the query knows what this is, okay, and what all column this particular table has, so that we can use these columns elsewhere in the entire query. You may use it in where clauses, in other joins, or in the select clause to display the values. You can do that. See now the result is product ID, sales date, amount, average salary. Average salary is only one for a table, right? We don't have any other condition, just selected average amount. Okay? The average amount is displayed with all of the records. Okay? Generally, if we have to display average salary, we cannot display any other columns, right? We have to definitely use a group by clause on other columns which are being used in the select clause. Okay? That is the basic thumb rule of group by, right? Whenever you use a group by, the columns which are selected in the select clause should be either applied with a aggregate function or they should be a part of a group by clause. Otherwise, it will throw an error. Okay, aggregate columns are not part of select clause. It will throw an error. Okay, but so we cannot display the aggregate values with a detailed record in general with the subquery. Right, we will calculate the average salary as per groups, but we cannot display a aggregate value with all detailed records. But here you see what is the purpose. Okay, I wanted the aggregate value with each and every detailed record also. Okay, this is my purpose. Okay, so what I can do, I can materialize the aggregated value with a table and I can give a name to it, so that these columns can be used elsewhere in the query. In the select clause also I can display the derived table values, okay, so that I can get such type of result set, okay, which is typically different than the normal aggregated queries or subqueries. Okay, I am displaying the aggregate value along with all the detailed records. Okay, so this is called a derived table. It is not that only one column should be derived. You can go for multiple columns also. Okay, within the subquery, you can create a derived table with multiple columns. See, in this example, production ID, average amount are the columns selected from the sales table, okay, with a group by of 1. It's a product ID level average amount has calculated, and that is materialized with the name called mytem, and the two columns which are selected in the subquery are named as product ID and average salary, so that this product ID and average sale can be used elsewhere in the entire query. So here if you observe, average sale is used to select clause of the outer query, and product ID is used to join the actual table again. Okay, so product wise average salary he has to display for every query. See, for product ID 20, the average of amount, sales amount is 15,600. So it is displayed with the rows of department product ID 20. Up to here. If it is 10, the average of sales amount is this one. Okay, so the detailed records of product ID 10 are having average salary of 5,200. Like this, you can display the average salary or average sales of that particular product along with its own detailed records. Okay, so this is the purpose of the derived tables. Okay, how we can create it? Within the query, we write the subquery and we will name it with as the name and the columns within the parentheses, so that the columns can be used elsewhere in the query. And which space this particular table use while it is being materialized? The spool space, because it is within the query. Okay, once this query executes and give me the result, all the space used by this query for the intermediate purpose will be flushed off. So along with that particular data, this derived table will also get flushed off. Okay, so this is all about the derived table. You can see some points here. So some characteristics are, it is local to the query and it exists only for the duration of the query. That is the lifetime. When the query is done, the table is discarded. It is incorporated into SQL query syntax itself. Okay, within the query syntax, the table is created. But are we using a create table syntax here? No, we are just using select and we are just naming it after the query. But we are not using a create table syntax here, but it is created within the SQL query syntax. Okay. Spooled rows which populate the table are also discarded when the query finishes. Okay, so the definition is not stored and the data is also not stored in any other column spaces. Everything, the definition and the data, everything is stored in the spool space only, and they remain till the query execution. After the query execution, everything will be finished, discarded. Okay. So as we are not storing the data definitions, it won't impact the data dictionary. Okay. Even though it is a table and we are creating within the query, it won't impact the data dictionary because it is not being stored permanently in the metadata. And then user spool space is used for materialize the derived tables. Okay, the space used by these materialized derived tables are, okay, the spool space. The spool space is being used to materialize the derived tables data. Okay, no DDL, not in DBC tables. Okay, no impact to the metadata because we are not giving the proper syntax to create this table, create table syntax. Okay, these are some real facts of derived table. Any questions?
No questions.
Okay. Okay. So the next type of table is called as volatile temporary tables. Okay, we generally call it as volatile table. Okay. As its name indicates, the volatile. Okay, that means it is also for some temporary purpose. Okay. Then what is the exact difference of this derived table with the volatile table? It is also a temporary table which we create. Okay. What happens and what are the characteristics of this volatile table? Okay. These volatile tables, okay, we create with a proper table syntax. Create volatile table table name, all the columns, primary index, everything will give. But only thing is we have this volatile keyword while creation of this volatile table. Okay. Why we create these volatile tables? Okay. Let's suppose in my application or in my script, okay, in an application script, I have some complicated values to be calculated once, and these values to be used till end of the scripts. Let's suppose script is having 100 SQLs, okay? And I wanted to calculate minimum, maximum, average with some count of a particular table, and these values to be used in all the 100 queries. Let's suppose. Okay, so generally what we do, we will calculate this average, maximum, minimum count, whatever we require, the aggregated values in each and every query, and we use them within the queries to do other calculations, and we will get our results done. Okay, so in 100 queries, if I do the same thing like selecting average of this, selecting sum of this, selecting count of it, maximum of it, so all the aggregated functions, whenever we use aggregate function, it has to process so many number of records, right? Because it is a aggregated value of so many of detailed records, so it has to process all the detailed records and get me the aggregated value. So it is a costly operation, and I am doing this costly operation again and again in all the 100 queries. So it is impacting my performance drastically. Right? 100 times I am doing the same operation of aggregations in all the queries. So instead of calculating these aggregated values every time, what we can do is, okay, we can store this in a particular table, and this table can be used as joins, okay, used with joins in all other SQLs. Okay, so that I am not calculating the values again and again, but I am using the existing aggregated or pre-calculated aggregated values, okay, in my SQLs with the help of join of that particular table in which they are existing as pre-calculated. Okay, so that is the purpose of the volatile tables, where it is being used in entire session. Okay, when I say in my script 100 SQLs are there, so it is my entire session. Okay, so the same values are being used in my entire session, okay, and these are pre-calculated and materialized for some time. Okay, so here when I do the calculation of aggregated values, okay, average, sum, count, max, minimum, I will insert these values in the volatile table, okay, which is created with the syntax of create volatile table and table name, okay, as select average of, minimum of, maximum of, sum of, count of, all the aggregate values I will count and I will put it in the volatile table. Okay, and the volatile table lifetime is till the session, not for a single query. Okay, so within the entire session, okay, whatever queries can use this volatile table, they can use this volatile table values, okay, which are inserted with the aggregated pre-calculated values, and they will use it. Okay. So it is discarded automatically at the end of the session, not within the query. It is discarded automatically out of the session. So once I log off from the session, the table which is created with volatile, okay, will also be flushed off. Okay. As the definition is not stored in the data dictionary, even though I am creating this table with a proper syntax, create volatile table, okay, as the lifetime is only up to a session, the definition is not required to store in the data dictionaries. Okay, so it is also not impacting my data dictionary DBC tables. So the definitions are not stored there because the lifetime is up to a session only. Okay. And then they also materialized in spool space. The space used by the volatile table is also the spool space, the intermediary workspace used by the queries. Okay, so when I log into my session and when I create the volatile table and insert the data, okay, it will use the spool space to materialize the data, and it can be used entire my session, and after my session, okay, along with all other spools, the volatile table spool also will get destroyed. Okay. So it not require any data dictionary access or logs. Okay, have a table definition that is kept in cache, that is pretty much spool. Okay, the table definition, and then design for optimal performance. Okay, what we discussed, optimal performance, that is example of optimal performance. Okay, instead of calculating these the aggregated values each and every time when we require, we have calculated at once, and all the rest of 100 queries are using this particular spool space, okay, in which the volatile table stores these pre-calculated aggregated values, and then they are avoiding calculation of the same values again and again. So we are saving so much of CPU of Teradata. The restrictions involved in using volatile temporary table include, you can have up to only 1000 volatile tables for a single session. In a single session, you can create up to 1000 volatile tables. Okay, each volatile table must have a unique name within its database. Okay, we cannot create two volatile tables with the same name in the same session. Volatile tables are always qualified by the session's user ID, okay, but not with the database. So no need to mention database anywhere. Okay, you create volatile table with the name of the table, but you don't prefix it with the database name. Okay, and while calling or while using the volatile table also, you don't use the database name. It will use the session's user ID, but not the database name to qualify the volatile tables. Okay, so these are some of the things we have to remember. Now let us see a simple example. Volatile. So how we can create volatile table? Create table. Create volatile table. V underscore table. Column 1, paragraph 5. Column 2, an integer. Primary index would be column 1. Suppose I am trying to create a volatile table. See, the table is being created. Now, if I want to insert the data, insert into v underscore table values. Okay. Insert completed. You can see the message here, insert completed, one row processed in the lower part of. Okay, and now if I try to select the data, what I am expecting? Select star from v underscore table. What should be displayed? The row which is being inserted now.
Yes.
But what I got? Select completed, 0 rows written. Okay. I have created a volatile table, I have inserted data, and when I am accessing the data, it is showing me 0 records. Okay, what could happen? Okay, so this is one more characteristics of volatile table, that okay, it has a default characteristic called on commit delete rows. So this is the default property of a volatile table. That means after commit of each and every statement, it will delete the rows.
Okay.
Okay. So to override this property, okay, while creation of the volatile table, we have to use one more word called preserve rows. On commit also, you have to preserve the rows. You have to instruct it, okay, at the time of table creation. Okay. If we don't put this while creation of the volatile table, even you do anything, any operation, insertions, anything, okay, after execution of that particular statement, it will delete the records. So In the next step, you cannot see the data. Yeah, that is the default property on commit delete rows. Okay. To hold the data for the entire session, not for the query, you have to use on commit preserve rows while creation of the volatile table. Drop table underscore table. So I'm just dropping the existing volatile table and then I'm creating the other volatile table, and now I'm inserting the data, and then if I select, it should display the data of volatile table. Okay. I have my data committed or preserved even after creation of even after the SQL of insert. Okay, so this is how we have to use a volatile table. So now it is a table, you can use it elsewhere. Okay, if I insert the average values in minimum value, maximum value here in this table, these values will be materialized for entire my session, so I can see the data and I can use the data in entire SQLs, the rest of the SQLs. Okay, that is the purpose of it. And while storing data in volatile table, we have to ensure it should be minimal data. It is not that some millions of data you are keeping in volatile table, because it is spool space. Okay, when you occupy more spool space, there will no spool space available for the rest of the queries. Okay, so I will go into out of spool space errors. Okay, so whenever we use volatile tables, okay, the data should be very much less, but it should be an output of complex calculation. Okay, that we have to ensure. It should be an output of a complex calculation, but the actual output should be very much minimal. Only maybe sometimes only one column and one row. Okay, maybe sometimes some 10 columns and 10 rows, like that. For temporary purpose, okay, less data should be stored in the volatile table, but it should be of a complex output. So we have to use on commit preserve rows. Okay. So now here, how many times I access the data, I can get it right within the session. So once I logged in, till I log off, I can access this table. But once I logged off and I logged in again with the same user, TD user, I have logged in with TD user again, and if I try to access this, it will give me an error. It is that object v underscore table does not exist. Why? Because
It is a different session.
it is a different session and the volatile tables are being accessed with the session ID prefix. The qualified with session IDs. Okay, so we cannot access it out of the session. Okay. Even though okay, the same user logged in two different client tools at the same time, okay, and one session, okay, in the one session the same user has created the table, and in another session, okay, if he tries to access, he cannot access the volatile table, okay, because it is dedicated with only one session, okay, not with the user also. Okay. You can see some examples. Create volatile table. On commit, preserve rows. You have to use this keyword. Okay, the default is on commit, delete rows. You have to override this property by giving explicitly the word on commit, preserve rows. And this log, okay, log is a production technique for the volatile table. Okay, it is nothing but the transaction journal, okay, which should be maintained with the volatile table or not. The log indicates that a transaction journal is maintained, while no log allows for better performance. That means, do we need to maintain the transaction journals for the volatile tables or not? If log is yes, it would maintain. If log is no, it won't maintain. If we don't maintain, the performance will be good because we don't have an overhead of writing all the transactions happen on the volatile table. Okay. Otherwise, you can mention it as yes, so that the all transaction logs also be stored for volatile table. And volatile tables do not survive a system restart. Obviously, when system restarts, the session will also go off. So once the server restart, once I establish my session again, I cannot see my volatile table which was created in the previous session. Okay, and you can use help and show commands on volatile table. Okay, once it is being created, you can use the normal Teradata commands, help table or show table. It will give you the definition and details of the table. Okay, even though they were not stored in the DBC tables, okay, from this pool, as it was constructed with the proper syntax create table, it can get us the details. Okay, so it is one example. Okay, select volatile, create volatile table or commit preserve rows. Just inserted some aggregated data in the table, and then we are using this in the next query. At VT underscore DAP design is the volatile table which we are using for the aggregated values. So what we are doing, minimum salary of the virtual table, volatile table, we are equating with the normal salary of the main table employee, and we are getting the details of employee who is earning minimum salary. Right? So for this purpose, let's suppose if I need to calculate this, what I should have done, I have to write a subquery here for calculation of minimum salary from the table. Then it will be equated to the salary of outer query. That should have been done. But now, as we have already calculated this minimum salary, we just used it with the join of the existing table. So these are some limitations of volatile table. The following commands are not applicable to volatile table. They collect statistics. What is a statistic statement? Have you seen that?
Yeah. Actually, I got the statement yesterday's tasks. So, I mean, it will speed up the query when we are running. Like, for example, let's say we are pulling the data from a particular table and so on so columns. So, for that, to speed up the process, we are using collect statistics table name dot column name.
Yeah. So we'll collect statistics of that particular data so that optimizer will have some information, okay, how the data is existing in that particular column, and it can run the query faster, or it can come up with a better execution plan.
I mean, collection statistics means, is the table do some like any kind of process?
Yeah, it will collect statistics on the data. So it is also a resource consuming statement. If I do collect stats on EMP column E number, suppose it is also being executed as a query. It will also go to all amps and see, okay, what is the data of employee number, how many unique values are there, how many duplicates are there, and then it stores the information in the metadata dbc.tables, dbc.collectstats. Okay, so if I want to see what all statistics I have on this table, help stats emp, it will show you on what all columns I have the statistics derived for the table. Okay, at what time I have collected statistics, at what time I have collected statistics, how many unique values are there in that particular table, in that particular column, everything you can see here. So they are stored. Actually, the statistics which are collected in the statement are stored in metadata, so that when you use the select star from employee, okay, when you select star from employee in the explain plan, if you see, this would use the statements, okay, whatever statistics collected, and it gives the data. See here, I'm getting high confidence. Okay, the select star from employee, it is getting high confidence because I have collected statistics on the employee number. Let's suppose if I drop these, drop stats on EMP column E number, I can drop also. And if I see the explain plan of select star from employee. See the confidence level. It is getting a low confidence of 18 rows. Earlier it was, let's see again. Okay, I'm collecting stats again. See, help stats, if I see, because I have dropped it, it was having only on department number. I don't have statistics on employee number. Now I am collecting stats again on the employee number. I am seeing the explain plan of this employee. Okay. Now it is high confidence of 9 rows. Can you see how it is impacting the explain plan of the optimizer? The statistic statement. If I have the statistics collected and updated, the optimizer thinks in a different way. If I don't have statistics, then it has to do some random imaginations. Okay, how it should be, how it could be, and then it will come up with its own plans, its own imaginations. But if I give the statistics that okay, this is having these many unique values, these many number of rows, everything, then while execution of the SQL, it has some information and it can come up with the exact plan.
Okay.
So the color statement is an optimization technique.
Okay.
So after loading the table, we generally do the collect statistics so that the optimizer will have updated statistics. How many rows are there? How many uniques are there? How many duplicates are there? So all these collect statistics, drop statistics, help statistics, everything can be performed. Okay, everything are not performed on the volatile table. Why? Because it is a volatile table and it uses this pool space, not the permanent space. So we cannot do the statistics. Okay, they are not applicable in volatile tables. Okay. And creation of secondary indexes, dropping of secondary indexes is also not done because it is all spool space. Okay. You cannot alter the volatile table once it is created. Okay. And the privileges you cannot access. Okay. And delete database user does not drop the volatile table because they are not associated with any particular database. They are associated with the session IDs. Okay. So you may think that I dropped database. Okay, I'm already in with the session. I didn't come out of the session, but I have dropped my database. Okay, then that it doesn't mean that your volatile tables also dropped. Okay, it will exist with the session ID. And volatile tables may not use access logging. Okay, access logging is a DBA technique. Okay, when we access the volatile table, some information is given in the access log metadata tables. Okay, that is not logged in case of volatile tables. Okay, and it cannot be renamed. Okay, it cannot be loaded with multi-load and fast load utilities. Okay, when we cover multi-load and fast load, you can see that, but we cannot apply these utilities on the volatile table to load the data. The volatile table may be referenced in views and macros also. Okay, you can reference it through views and macros, but within the same session. Okay, so whenever you use the views and macros with the volatile table, prior to using this, you have to ensure to create that volatile table and insert the proper data. Okay, so these are the characteristics of the derived table and the volatile table. So we have left with one more type of table called global temporary, and we'll cover it in the next class, Tuesday.
Okay. Okay.
So any other questions up to here in the topic? The spool space,
No.
pump space, derived table, volatile table, characteristics, why we use it, how to create it.
Yeah, no questions.
Limitations.
Everything is clear as
Yeah.
of now.
Okay. So we'll see the next topic, global temporary tables, in next class, Tuesday, 8 a.m. IST, 8:30 a.m. IST.
Okay.
Okay. Thank you.
Yeah.
Lokesh? Lokesh?
Yes, sir.
Yeah. Okay.
Yes, sir.
Yeah. Ask Kapil to send that recording session to Nizam.
Okay, sir.
And how it's going on, Lokesh, for you? Are you able to do that exercise part, the case study?
Yes, sir. Yesterday's I didn't join the class, sir.
Hmm.
But today I watched that class and do these exercises.
Hmm. Okay.
Because sir, in nowadays the internet connection is very bad
Oh.
in office. The working is going on of a telecom company. That's
Uh-huh.
why
Uh-huh.
that's why I am not able to even record the session of Teradata.
Okay. Okay. Fine then. So we'll meet on Tuesday.
Okay,
And tell them
okay,
to
sir.
drop email. The next class is on Tuesday. I think they already know. Still, it would be better if we can
Okay, sir.
drop
I
it.
will. Yes, sir.
Yeah.
Okay,
Thank
sir.
you.